If ionic equivalent conductance given, number of equivalent of ion is equal to charge on the ion by total charge, and equivalent conductance is equal to number of equivalent of cation into equivalent conductance of cation plus number of equivalent of anion into equivalent conductance of anion. For this concept, I want to add one problem. The problem is the ionic equivalent conductivity of C2O4 minus 2, K plus and Na plus ions are X, Y and Z Simon centimeter square equivalent inverse respectively. Calculate equivalent conductance at infinite dilution of COO-Na, COO-K. First of all, total charge on cation and anion. Total charge on cation it is plus 2, anion is minus 2. Now we have the formula to calculate number of equivalent of ion is equal to charge on the ions by total charge. Charge on the ions by total charge. Now first we'll calculate equivalent of C2O4 minus 2. Charge on the ion is minus 2. Total charge on the anions is also minus 2. So it is 1 equivalent. Similarly, equivalent of Na plus is equal to charge on the sodium is plus 1 by total charge on the cation is plus 2. So here it is 1 by 2 equivalent. Similarly, equivalent of K plus is plus 1 is the charge on the ion, total charge on the cation is plus 2. So here it is also 1 by 2 equivalent. Now lambda EQ naught of COO-Na, COO-K is equal to lambda naught EQ of C2O4 minus 2 plus 1 by 2 into lambda naught EQ into Na plus, because the formula already told number of equivalent of cation into equivalent conductance of cation. Similarly, number of equivalent of anion into equivalent conductance of anion. Then here also 1 by 2 lambda naught EQ of K plus. If we substitute the values here, lambda naught EQ is X for C2O4 minus 2 plus 1 by 2 into Na plus equivalent ionic equivalent conductivity is for Na plus how much is given? Y. Sorry, for Na plus it is Z. So Z plus for K plus it is Y by 2, plus 1 by 2 into Y. So we'll get here, if you take the LCM 2x plus Z plus Y, it is Simon centimeter square equivalent inverse. We can calculate by using this concept equivalent conductance at infinite dilution.